I think I started to understand Rust memory model, or I think it's also called Rust ownership. And by that I mean when a variable is moved, what does it mean for a variable to be owned, what does it mean for a variable to be borrowed, and maybe other stuff. So what I did was to go through this page. I've also tried these examples myself locally, and now what I want to do is to actually explain this with my own words. I've also added some additional questions for myself, which I also wanted to expose about Rust's strings, to be more precise. And so I'm going to jump into the code, but just before I start, just be aware, in case you are watching this, that my understanding is not fully stable. It's not very solid. It's just an initial understanding of how things work in Rust, but I think we all have to start somewhere. So I'm going to jump into my editor. I have essentially copied some of the things, some of the snippets from here, and I'm going to try to explain this in my own words. I think this could be beneficial, at least for me. So at this line, essentially what is happening is that a string is allocated on heap. The distinction between heap and stack allocation is very important, and in this case this string is allocated on the heap, meaning that its size can grow, and I think that's all. But in essence, we are dealing with dynamic stuff, so it's not as if we were having just a number. A number can be represented, let's say, statically. If we declare that it is an unsigned integer, then we know its range, although the number itself might be dynamic. But when you talk about strings, which are essentially sequence of bytes, then the sequence can grow or not grow. I don't know the opposite for grow. Anyway, so here we are allocating on heap, and here we are taking the ownership. Basically what this results to is an error, a compile error, and I think it's nice that the Rust compiler, or I think it is the Rust language server, can do some parsing, some compilation before I actually run the code, so that I'm warned for errors before I actually run the program, which is nice. So at this point it says that the value s has been moved. And what does it mean? First of all, I would like to see what essentially is behind the string with capital S. So for that I'm going to dive a bit into the source code, and at some point I'm getting this. So string is essentially a struct, and it has a property which is a vector of unsigned integers. If I step into vec, then I'm getting into this is another struct which has the metadata, as in the length, and I think the buff is what essentially points to the sequence of bytes. As far as I can see, things get really complicated from this point, and I think I won't try to understand it like right now. So I think it's safe to presume that vec will at some point indirectly point to a sequence of bytes. And if we go with this approach, then we can also represent our string like this. So S will be like this. S will be essentially this string container, which has a property vec, which will at some point point to the sequence of to a sequence of bytes. And by doing this, by calling the take ownership function, So I'm going to number them just to make sure it's all clear. So after step 2, some different things might happen. So here we initially had S pointing to let's say S was pointing to this, although the term pointing might not be the most accurate. And now after this, we also have some string that also points to the same structure. And so as you might have understood from the error, this string, to my understanding, will move in a way that it belongs only to some string and not to S. So this one will be faded out. I've also asked myself why cannot both point to the same structure? Well, it is also mentioned in the documentation, but now that I present this, it makes sense because, for instance, at this point, some string goes out of scope. So it makes sense that this structure will have to be cleared. But if this is cleared, then S becomes a dangling reference. So I think, to my understanding, that Rust, in order to avoid this, it essentially made it in such a way that a variable, or let's say a data structure or a container for a data structure, can be owned only by a single variable. So in this case, string will be moved, this container will be moved only, I should have grouped those anyway. So after the function, in the function, some string will be the one that will own string, and S will essentially be invalidated. So S essentially disappears because now the string structure has been moved to some string. But after some string goes out of scope, which is this sequence here, okay, that should have been a different color. Okay, and at this point, after this step, string S no longer exists because it has been invalidated because the string structure has been moved to some string. But since some string also became out of scope at this point after this function, then basically S no longer exists, and in essence what this means is that this structure has gone out of scope completely, so it has been completely removed. This is because, yeah, the string container has been moved. But if we borrow this, so instead of moving this, we simply borrow it, what this means is essentially using a reference to that. And just notice that we are using as ref. And to my understanding, this ampersand str is essentially, I think it's called a string slice or something like that. And to my understanding, which has also been checked with an AI chat, this str is essentially a sequence of bytes. So what this means in our diagram, which I'm going to create a new one, basically, to my understanding, str points directly to this. And this is not owned by anybody. This simply exists in memory. And that's, I think, an important thing to understand. And I hope I understand it well. If I didn't, then that would be a bit awkward. But coming back to our example, the reason this works is because here we have essentially passed, we essentially have borrowed hello to this string, to this function, and essentially in this function body only this has been borrowed by this, meaning that the ownership hasn't been moved, meaning that S will still be pointing to this string container. And so because some string will have the borrowed version of hello, then when it goes out of scope, it simply returns the borrowed value. So borrowing is essential because semantically it means that when you borrow something, you have to return it back. And this is essentially what's happening here. You are taking just a reference to the sequence of bytes that represent hello, and after you're done with this function, after this function goes out of scope, then that thing that you have borrowed will be returned back. And there is also one more subtle thing that I want to touch on, which is this function. And notice the small difference, which is that this time we have ampersand string, and to my understanding, which is of course nothing new because it is in the documentation, this will be a pointer to this. So in this example, string, let me also bring this back. So considering this, if we call borrow ownership owned of S, let me put this first. Okay, then string will be, and if we use ampersand string with capital S, then some string will essentially be a pointer to this. And this also means that it is a way to borrow this. Yeah, I think it makes sense. So I'm going to put it like this. Which means that when this sum string will go out of scope, meaning when this function will end, then this can simply be removed, and the ownership hasn't actually changed because this is still S at the end of the day. So after this function will be finished, then only this will go away, will be removed, I guess, and string and S will remain basically intact, because the same thing happens when using references. You actually borrow the variables, the data structures, the containers, however you want to call it. I think this is what I wanted to just share. I know that, and I have realized that now I don't fully understand what's going on, but I have that understanding that allows me to move forward in my learning, and I just wanted to share this, maybe even as a practice exercise, to make sure that I fully understand even this small bit of what essentially means memory management in Rust. Okay, I hope this made sense in some regard. It helped me, that's for sure. And I'll keep on going. I'll keep on doing such videos on Rust. I think it's fun to try to come up with my own understanding of this. Although, as you can see, those are similar and those are essentially the same thing. Of course, those are better explained than my diagrams here. But I think this is a healthy thing to do for your understanding. And it's also fun in some regard. And this is also a good way to understand what you still lack, what are the missing parts in your understanding. Okay, I think I've talked for more than 10 minutes, and I'm going to end this video here, and I'm pretty sure there are more to come about Rust and about programming in general. So thank you very much for watching, and I'll see you in the next one.